Hey there, everyone. Welcome back to our channel. If you're passionate about technology, machine learning, or artificial intelligence, you've landed in the right place. Today, we're diving into a fascinating topic that's transforming how machines understand and predict sequences of data. Yes, you guessed it right. We're talking about LSTM networks. So, grab a cup of coffee, settle in, and let's explore this powerful technology together. Now, you might be wondering, what exactly is an LSTM network? And why is it so important in the world of AI? Let's break it down. To understand LSTMs, we first need to know about traditional neural networks. Standard neural networks are great for processing data, but they often struggle with sequences, like time series data or natural language. Imagine trying to predict the next word in a sentence without remembering the previous words. Sounds tricky, right? This is where LSTM comes into play. LSTM stands for long short-term memory. It's a special kind of recurrent neural network, or RNN, designed to remember information for long periods, making it ideal for tasks like language translation, speech recognition, and even stock market predictions. So, how does an LSTM work? Let's break it down into simpler parts. An LSTM unit consists of three main components: the cell state, the forget gate, and the output gate. 1. Cell state. This is like the memory of the LSTM. It carries relevant information throughout the sequence and helps the network to remember long-term dependencies. 2. Forget gate. This component decides what information to discard from the cell state. It takes the previous hidden state and the current input, runs them through a sigmoid function, and outputs a value between 0 and 1. If the output is closer to 0, it means forget this, and closer to 1 means keep this. 3. Output gate. Finally, this gate determines what information to output from the cell state. It also uses a sigmoid function to control the flow of information based on the current input and the previous hidden state. Let's look at a practical example. Imagine you're working on a language translation model. When translating a sentence, it's crucial to remember the context of earlier words. For instance, if you're translating "the cat sat on the mat," you need to remember that the cat is a subject to ensure the rest of the sentence makes sense. An LSTM can do this efficiently by using its cell state to carry the context of the entire sentence, while the forget gate selectively removes less relevant information. Now, you might be thinking, where do we actually see LSTMs in action? Well, they're everywhere. Here are a few exciting applications: natural language processing, LSTMs powered chatbots, language translation services, and sentiment analysis tools, allowing machines to understand and generate human language effectively. Speech recognition, technologies like Siri and Google Assistant use LSTMs to comprehend spoken language, helping them to provide accurate responses based on context. Time series prediction. In finance, LSTMs analyze historical data to forecast stock prices, making them invaluable for traders and analysts. Music generation. LSTMs can even compose music by learning patterns from existing songs, creating unique pieces that mimic human style. And here's a fun fact: a study found that LSTMs outperform traditional RNNs by over 20% in various sequence prediction tasks. This impressive performance is one reason why LSTMs have gained popularity in recent years. So, to summarize, LSTM networks are a specialized form of recurrent neural networks that excel at processing sequences of data by remembering long-term dependencies. With their unique architecture, including cell states, forget gates, and output gates, LSTMs have proven to be game changers in fields like natural language processing, speech recognition, and time series forecasting. If you found this video informative and want to learn more about artificial intelligence, machine learning, or any tech-related topics, make sure to hit that like button and subscribe to our channel. Don't forget to ring that notification bell so you never miss an update. Thanks for tuning in, and we'll see you in the next video. Keep questioning, keep learning,